Okay, this is part 3 of Chapter 1, so let's continue the discussion on mathematical models. So let's talk about this simple example for the production problem we said. So I talked about objective functions, I talked about constraints, so let's begin to look at how we treat this and how we express it. So we want to maximize profit, and so in this case, if 10x is our objective function, that is the 10 represents how much profit we earn from each unit. X represents how many units we'll be able to produce, 10 being the coefficient. And then we say subject to, sometimes abbreviated as ST, and we subject to some constraints. And we said earlier that each unit X required 5 hours to produce, and we only had 40 hours available production time. Therefore, we express that constraint as 5x must be less than or equal to 40. That's our first constraint. A constraint that we often also employ is if a given variable cannot be expressed in a negative way. And so in this case, we say x must be greater than or equal to 0. We can produce 0, but we can't produce a negative number of units. Now, this is a very simple model. And I said earlier that why would you want to use models when things are complex? Well, if it's very simple, as we've expressed here, we might do something like trial and error. These are the kind of things you might do in your head. You might make a little chart, but trial and error is interesting and useful when you have small scale efforts to try this. So we could express this in a manner where we say, well, if we produce 0, our profit will be 0. Is it a feasible solution? Yes. Right? And we could say the same thing if we produce 2, we'll get a profit of 20. The 10 production hours used, is it feasible? Yes, it meets all of our constraints. If we say x is equal to 4, we get $40 profit. 10 times 4 is 40. Total production hours used, and 5 times 4 is 20. It's still less than 40, yes. And x is greater than or equal to 0, yes. And we could find this until we get to 8. But we could say, oh, how about we produce 10? Oh, we could have $100 profit, but we fail here in terms of the number of production hours because that would be 50. 5 times 10 would be 50. It's not less than or equal to 40. Therefore, it fails the feasibility test. So we can't go to produce 10. We can't produce 12 and further on and so forth. So our optimal solution here in this case is 8 in terms of maximizing profit. All right, let's look at another example. So this builder, this PDC, builds a certain house. They sell their house at a price of $115,000. They've got annual fixed costs. They've identified as $40,000 per year. Land for each house, it costs $55,000. The materials and the like run for $30,000, and labor is $20,000. Now let's analyze this in terms of a mathematical expression. Now, here's an example of where I might ask you a question to write a model, an expression for annual total cost and for revenue or for profit and a break-even point. Let's see how this might be done. So for the total annual cost, I might express that cost as a capital C. So for the cost of X, it will be expressed as variable cost per unit times the number of units sold, plus the annual fixed costs. So our total annual cost for the organization would be $105,000, which is the sum of all of the land, material, and labor costs, times X, times how many houses we produce, plus $40,000, which we've identified as our fixed cost on an annual basis for the organization, even if they produce 0 homes. Revenues are easy. If I say total revenue, it's going to be $115,000, which is the sale price of each home, times X, however many sold homes we sell. Therefore, our total annual profit is, hopefully most of us are aware, would be our revenues minus our costs. So we already have a revenue expression here, minus our costs. And notice how I express the costs here and in a parenthetical form. You don't merely want to insert the 105,000x plus 40,000 in that equation without including it parenthetically, because that would change the math in the equation. So be careful how you do these. So I asked you a fourth question, the break-even point in terms of number of houses, the idea that where profit is 0, where profit, you neither have a loss nor do you have a profit. So TP, if you will, is equal to 0. We had an expression earlier where we identified total profit as the total revenues minus the total costs based on how many houses you produce, which we represent as X. So if we set total profit equal to 0 and we use this equation and merely solve for X, we get the answer of 4. Let's walk through that quickly. Take this expression 115,000 and break it down. Right? So we get 115,000x minus 105,000x equals 10,000x minus 40,000. That stays because that's a negative expression here of the parenthetical expression. So it's minus 40,000. I can move that 40,000 to the other side of the equation. 40,000 equals 10,000x. And then I simply solve for x, placing 40,000 in the numerator and moving the x over into the denominator, that side of the equation, and I yield an answer of 4. Now, another way to do this is to use Excel, and we're going to do that data here in example as well. So I have this Excel file model on Canvas. It says Ponderosa Development. So you can find it yourself in the Module 1, Week 1 topic, and this is just a representation of that spreadsheet. And we would populate the data that we already know, and these are how we would calculate the formulas: revenue, cost, and profit. Pretty straightforward, pretty simple. If you have any questions about how to set up Excel or how you enter formulas into Excel, please feel free to reach out to me. Otherwise, I'm going to assume that most of you have a basic and functional understanding of how to implement Excel and point to different cells and how to enter formulas. Okay? Thank you. Now here's another example. It comes from the textbook on the pages I've identified, 14 to 16, and then I have an Excel model on Canvas here. This company manufactures a storage unit we denote as X. It costs $2 to make. There's $3,000 of non-recurring setup cost. The total cost can be expressed like this: of $3,000, which happens independent of how many units you actually make, plus $2 times X, being how many you make. If it sells for $5, a revenue model can be set up as 5 times X. However many X's you make, you can realize a revenue of 5 times X. So your profit is a pretty simple expression as well. So it's, of course, our revenues minus our costs. Again, note the parenthetical capture of the expression for cost. So if I say to you, what's the profit or loss for sales of 500 units or 1,800 units? What's the break-even value? Take a look at the model that I have on Excel, and you'll see how to do that. The Excel model that's on Canvas. Thank you. All right, one more example from the text. This is actually on page 22, problem 1-13. This company Macromedia offers a training seminar. There's fees per student. Fixed costs are $9,600. Computers cost $120 per unit per day. Remember that it's a 2-day seminar. So again, I've got an Excel template on Canvas. So if I asked you to develop an expression for cost, for profit, what would profit be if there's 30 students to enroll, and what would be the break-even point? Well, let's walk through that. I've got the example here coming up on the next slide. All right, so how would we calculate that? Again, the total expression for cost would be our fixed cost plus $120 per computer per day times 2 days. We know each is a 2-day seminar times X, number of students that we enroll. And our expression for the total profit and revenues minus cost. Revenues are easy, $600 per X per student enrolled. And if we had 30 students enrolled, we'd have a profit in this case of the revenues would be $18,000, and we have our cost of $9,600, our fixed costs, and our variable costs would sum to be $7,200, $30, 30 students times $240 each. We have our net profit of revenues minus costs of $1,800. So what's the break-even point there? We would see a break-even point of using profit equal to 0 and then solving for X of 26.67. We can't have a fractional person, so we need to round that up to 27. So I hope you understood these basic examples. There are some slides here that you're going to want to reference for the first test. So keep those slides handy in the non-video portion. I've got the slides only, and so you'll need that for the test. You're going to have 2 hours, 120 minutes to answer 10 questions. There will be some problem solving, some mathematical expressions to conduct in the first test. If you've got any questions or problems, feel free to reach out to me. You can only take the test once. You can't pause it and go back to it, but if you've got questions, take a screenshot, send it to me, and I'll try and help you work through it. Thanks very much, and I look forward to talking to you in the next chapter.